Ever wonder how AI can really understand both images and text? Like not just recognize a cat in a photo, but reason about why that cat is sitting on a couch. Today, we're diving into a breakthrough that's changing how AI tackles complex, multimodal questions. Let's start with the basics. Large vision language models, or LVLMs, are like supercharged AI systems that can process both images and text. They're used in everything from answering questions about photos to analyzing medical scans. But here's the catch. Even though they're powerful, they often struggle with reasoning, like connecting visual clues to a question in a logical way. That's where chain of thought, COTI, prompting comes in. Think of COTI as AI's way of thinking out loud. Instead of jumping straight to an answer, the model first generates a rationale, like a step-by-step explanation of how it's solving the problem. For example, if you asked, "Why is the sky blue?" the model might first reason, "Sunlight scatters in the atmosphere, shorter wavelengths like blue dominate," before giving the final answer. But here's the twist. Our experiments show that even with COTI, many LVLMs ignore the rationales they generate. It's like a detective writing a detailed report, but then ignoring it when solving the case. The model relies mostly on the image or text, not the intermediate steps. This means their answers can be less accurate or even wrong. So how do we fix this? Meet Rationale-Enhanced Decoding, RED, a clever new method that forces the model to pay attention to its own reasoning. Instead of just using the image or the text, RED makes the AI balance two perspectives. 1. What does the image say? 2. What did the model reason earlier? It's like giving the AI a checklist. Okay, I saw this image and I thought X, Y, Z. Let me make sure my answer matches both. By mathematically combining these two sources of information, RED ensures the final answer is grounded in both the visual data and the model's own logic. The results? Massive improvements. In tests across multiple AI models and datasets, RED consistently outperformed traditional COTI methods. And here's the kicker, it doesn't require retraining the model. You just tweak the way the AI decides its next word, making it a quick plug-and-play upgrade. Why does this matter? Well, imagine an AI that doesn't just guess answers, but explains how it got there. This could make systems more reliable, especially in critical areas like healthcare or autonomous driving. Plus, it's a big step toward AI that's not just smart but transparent, so we can trust its reasoning. Now, here's a problem you might not have considered. Ever asked an AI a question and gotten an answer that sounds too confident, like it's making things up? Imagine pointing a robot at a photo of a cat, and it insists the animal is a tiger. That's what we call AI hallucination, when models invent facts that aren't there. It's a big deal, especially when AI is used for things like medical diagnoses or legal advice. But here's the good news, scientists are working on a fix. Let's break down how RED tackles this. Traditional COTI methods let models generate reasoning steps, but don't enforce alignment with the input data. Think of it as a student writing a detailed essay, but ignoring the textbook. RED solves this by linking the model's internal reasoning to the actual image, or text it's analyzing. To test this, researchers used a model called Gemma-3-12B and a dataset called GQA, which pairs images with questions. They tracked how the model looks at images and text using attention scores. Think of it as a heat map showing where the AI focuses. Then they tried different ways to balance image and text clues, pure text reasoning, mixing both, and finally RED. Here's what they discovered. Text-only reasoning, traditional COTI, led to wild guesses. The model would hallucinate details not in the image. Mixing image and text didn't work well. It was like asking two people to solve a puzzle in parallel without talking. RED, however, was a game changer. By combining image and text cues, like an AND operation, it cut errors and boosted accuracy. In one test, it improved answer quality by 2%, while reducing hallucinations by 7%. But here's the twist, RED isn't just about accuracy. It also makes AI more transparent. By forcing models to tie answers to specific reasoning steps, we can spot when they're unsure or biased. Think of it as giving AI a voice of reason, so we can trust its conclusions. So the next time you see an AI answer a complex question, remember, behind the scenes, researchers are working hard to make sure those answers are well thought out, literally. Thanks for watching and stay curious.